repeat some of the measurements that we have been doing at the power plant. Okay. So the plan over there is that we will repeat the 20-gram detector as well as a 1 kilo germanium detector as an underground lab. And as the future evolved, our collaborators are also building a 10 kilo germanium array, and then with the liquid argon anti-competence, and then trying to get both germanium and the liquid argon technology in hand. And then several years beyond, down the road, they have an eye towards a 1 scale experiment, as well as using germanium to study the case of using germanium for double beta decay surface. And meanwhile, of course, we understand the background and materials over there. Okay, so a very quick tour on what is happening in the last few years and over a region which started off as a wilderness, but now it is an area of intense interest. So light waves has turned from a wilderness to mainstream. So this is a fair statement because they are real dedicated conference of several days dedicated to this topic. So as mainstream as that. So intriguing hints in controversial claims. So there are no competing evidence, but they are intriguing hints, including the latest result on the CDNS2 on silicon. For us, the taxonomy, we have placed a competitive and relative result on the light mass wheel using our KV detectors. In fact, we are the first group that gets into this wilderness and then witnessed and contributed to its evolution. And then we have shown that we can manage, we do competitive results even with a surface laboratory. And we have probed and excluded the Cogent 2011 region and also explained basically what happens over there. And we expect improvements via various upgrades. We are still measuring, and then with better detectors and things that will be better. The same design is now being deployed at the new underground lab, which is the deepest operating underground network in the world at Jhongli. So we expect better sensitivity over there. But we also should look for photo storage on CDNS flight, as well as I didn't mention that, but of course in Xenon, they also have programs to get down in energy, and so both Xenon detector, both of these are big experiments, and they are also have very solid and interesting plans in this case, the new detector technologies that are being tried out to study this low mass regions. So generically, so this is a parameter may and can use surprises. So we stay tuned. Thank you.
Questions or comments?
Yes.
So you had some projected taxonomy thing which will cover the region of CDS and
we were talking about everybody wants projected curves. Okay, yes. Now I have to look at this required 100 EV threshold, 10 kilogram years 1 centimeter. So this is background. With this background, with this exposure, with this threshold, with this background, then this is the curve.
So you have a schedule for that?
Schedule? Oh, no. Okay. Now, we are moving down at steady. 10 kilogram years will take a few years. Okay. And then once CDG is closed, it will be a factor of 2 or 3 away. This one is it depends on technology. So we are now getting to maybe this measurement is based on 500. So right now we probably can do 300. So this 100 EV threshold is not in 10 yet. But so we are moving in outer space now, even with the technology, and this would be a goal. And from the manufacturers and then within us who works on this, it may be realistic in a few years. So this is the status.
See that alone? Something?
See that? Okay, now we are taking data. So the sensitivity is also around this region. We have data. We could have plot another extrusion plot, but before that we really plot it out, then we will not show it. Okay. So also this among friends, of course, we plot our data is presented as a limit. But mathematically, we can also draw a allowed region. And the allowed region, of course, would be here. But then this is not what we choose to do in the paper.
Usually we talk like
use it several years ago, yes.
No, I'm saying, can you go very region? You just want to go down very small mass region.
Okay.
It's very difficult, but if you go down that region, can you do that?
But this talk is mainly trying to focus on this region. Of course, there is a lot of activities here at the high mass region.
Yeah.
But now, because high mass region has been explored for 20 years, so now it's more or less converged to only two experiments, xenon as well as CDMS. So both of them has been working on that for 20 years in the case of CDMS. So indeed, the CDMS, this is the CDMS curve. So they will go down here, and then they are dominating the sensitivity over there. And then they are still going, of course, the super CDMS project, which the super CDMS project would have good sensitivities.
So
at the several hundred dB region, yes.
So they won't say soon about this minus heaviness.
They are constantly pushing the exclusion limit on the high mass as well.
So they haven't seen anything.
They haven't seen no hints, but sensitivity and limits are improving, yes. But there are no hints, unlike at low mass range. At the high mass range, there are no hints. No experimental hints or any anomalies at the high mass range, only better and better limits, making theories like more about it.
Okay, any more questions? Because everybody's getting hungry, so. Okay, the second speaker again. And all the speakers in the morning session. Okay, so thank you.